So for example 2, we were using the equation f of x equals x to the fourth minus 2x squared to determine each of the following. So we had some problems with the calculator and these are with the calculator. The first part was without our calculator. So for part A, we're just determining the domain. So our domain for any polynomial would be all real numbers. So we put negative infinity to positive infinity. The reason is there's no limit on what x could equal in this function. So we just need all real numbers represented in interval notation. For the x-intercepts, we need to solve it the way we have solved things in the past with Math 3. We just need to factor out the greatest common factor, set our function equal to 0. We get x squared times x squared minus 2. Then we can set each factor equal to 0 and finish solving. So we end up with x equals 0, and over here we get x equals plus or minus the square root of 2. So we have 3 x-intercepts all together. We have one at the origin, one is at the square root of 2, and one is at the negative square root of 2. For the y-intercept, we always can plug in x equals 0 into our function. So when we do that, we just get 0. So the y-intercept is just also at the origin 0, 0. For symmetry, we just have our equation, so we're going to plug in negative x and see what happens. So everywhere there was an x in our function, we replaced it with negative x. And then when we simplified, we noticed that no signs changed by doing that. So that means this is an even function, and it would be symmetric about the y-axis. So let's look at the calculator part. I've already typed in the function, so we can take a look. We had to figure out the range. So if we take, let me scoot this over a little more. If we take our calculator, type in our function, and hit graph, let's see what happens. So we can tell that our graph comes down, goes up, comes back down, and goes up forever, but then it doesn't go down forever. So our range needs to depend on how far down it went. So first we could change our window just to show us a little bit better view of things. So if I just divide all the 10s and turn them into 5s, I can kind of zoom in a way I know what the numbers still are. So now I can see a little better. So it looks like it's going down to -1. We could also check our table and make sure that it did indeed go down to -1 before it went back up. So our graph has a range of -1 to infinity, and it would equal -1. There's no reason it wouldn't. So we do put a bracket on the -1. The relative min and relative max we can find on the calculator. We can do second trace 3, and we can either trace over or type in values. But if I trace over to the left of this minimum I'm looking for and hit enter, then trace to the right of it, but not too far, and hit enter twice, it will land right on the minimum value of -1, -1. So I wrote that down. Then I can find the other one, and they definitely look like they are symmetrical. But if I just want to find it, I do second trace 3 again. I need to move to the left of this other relative minimum point and hit enter. Then I need to move to the right of it and hit enter twice, and it will find it for me. So that rounds or definitely equals 1, -1 again. So I have -1, -1, and 1, -1. So they definitely were symmetrical. And then this point is my relative maximum. It looks like it's definitely touching at 0, 0. We could even just check our table to find out that there is indeed a point at 0, 0. And that would be the relative maximum. You can also see the relative minimums are there too. The -1, -1, and the 1, -1. So let's look at increasing and decreasing. So if we look back at our graph, we can check and see where it's going uphill. So it's increasing from -1 to 0, and then from 1 to infinity. So I wrote those down for increasing. Decreasing, it's decreasing or going downhill from left to right from -infinity to -1. Then it's also going downhill from 0 to +1. So I put both of those are decreasing. And the little U sign in the middle just means that it's increasing between -1 and 0 and between 1 and infinity. And it is decreasing from -infinity to -1 and from 0 to 1. Then there's no intervals where it is constant, because there's no intervals on our graph that look like it's flat or not increasing or decreasing. So we just put none for constant. And then J wanted us to find f of 3. So that's where x equals 3. We could quickly just check our table. And we see that x equals 3 would give us 63 for the y value. And then where f of x equals 8 means where the y value would equal 8. So that's where x equals 2. And we also have another one at -2. So we just need to put both of those right there. But notice they're really easy to check just looking in your table. So that's it for example 2. There'll be another video for 3 and 4.